So for these notes, we're going to talk about rational and irrational properties. There is 3 learning targets for this. The first one, it says, I can explain why the sum or product of 2 rational numbers is rational. So the first thing I want you to do is to annotate. So the word sum means adding. The word product means multiplying. Now, instead of writing the word rational numbers, there's a letter that stands for rational, and it is Q. The word is means equal. And then rational, once again, is the letter Q. So below I have it separated into 2 boxes. Notice the only difference is the operation. So the left is going to be multiplying, and then the right property is going to be adding. It doesn't matter. You can have Q plus Q equals Q on the left side. So the first thing you want to do is think of a rational number, any rational number you can think off the top of your head. So for example, a rational number would be -1. Then the times, another rational number would be 4. So I have my rational times my rational. Now if you use your mind or your calculator and you get -1 times 4, it's going to give you -4, which is also a rational number. And you want to make sure, if you want, you can use your page 1 of your notes. Negative numbers are integers, which fall into the rational. 4 is a natural whole or integer, so that also falls under the rational numbers. And then equals -4 would be an integer, which is also a rational number. Now, for the second property, rational plus rational equals rational. Once again, come up with some type of number, any number that you can think of. So I'm going to choose 1/3. 1/3 is definitely rational because it's a fraction. Also, if you make it a decimal, it's 0.3 repeating, and repeating decimals are that. Plus, let's just keep it simple, 2/3. So this is rational plus another rational. And if you put that in your mind or in your calculator, you're going to get 3/3, which simplifies to 1, which is also a rational number. So for the second learning target, it says I can explain why the product, again that's multiplying, sum, which is adding, of a non-zero rational number and an irrational number is irrational. The reason why we have to make it a non-zero is because if we make it a 0, then it becomes rational, and then we would have to change the property. So just for this class, for right now, we're just talking about any rational number that's not 0. So for this property, we have rational, because that's our Q, irrational, which is our P, equals P. So you can pick any number that you want. I will pick -2.5. I know that's rational because it's a terminating decimal, it ends, times everyone's favorite irrational number, pi. Now if you plug that into the calculator, -2.5 times pi, you're going to get -7.85398 ... So this ... means it's going on forever, but notice that there's no line above the numbers. That means it does not repeat. So this is rational times irrational, and it produces an irrational. So we know that we did it right. For the following property, Q plus P equals P, once again, come up with any rational number that you want. So I'll do the square root of 16 plus the square root of 2 and see what that gets us. The reason why square root of 16 is rational because you can simplify it. The square root of 16 is 4, so that gets us our rational. Then 4 plus square root of 2 is going to get us an irrational number. So it is 5.4142. Sorry, I didn't mean for that to happen. Dot, dot, dot. So once again, rational plus irrational equals irrational. So that would be right. The third one's a little more challenging. It says, I can explain why the product or sum of an irrational number and an irrational number is rational or irrational. So it's actually two different problems in one. So if I choose irrational, let's just say pi times square root of 2, pi times the square root of 2 will get you 4.44288 dot dot dot. So this is irrational times an irrational equals irrational. This one is going to be challenging